So to get the market equilibrium, we set quantity demanded equals quantity supplied. And when we do that, we can set these two equations equal to each other. We get P equals 8 times T. 2P equals 8. And that gives us that the price equals 4. And if we take the price and sum it back into either equation, we get that the quantity also equals 4. So going over to a graph, we can label that on here. The price, M, denoting market, equals 4. And the quantity here also equals 4. Okay, so given this, we calculated the consumer surplus. And we said that is 1/2 the base times height of the triangle that is outlined by what is below the demand curve and above the price that the people who are purchasing the product. Okay, so our consumer surplus is this area right in here. Unfortunately, I don't have my color chalk today, so the diagrams might not be quite as clear, but we'll try to use some shading to identify what's what. So consumer surplus below the demand curve and above the price that the demanders are paying. Okay, so going back to that, we have 1/2 was the base. The length of the base goes from 0 here to our market quantity of 4. So that's 4. And then the height, and we have 8 up at the top of this, and then the price they're paying is 4. So the height of that is the difference, 8 minus 4. And that gives us 1/2 times 4 times 4, which is 8. Producer surplus, in similar fashion, is the area that is below the price that the producers receive for the good, so the market price, and above the supply curve. So producer surplus is right here. Okay, so getting the area of this triangle, what's the base? Well, the base is the same as it was before. It's going to go from 0 to the market quantity of 4, the length of this. And the height of this triangle goes from the price 4 down to 0. The supply curve meets at the origin 0. Times 4 times 4. So in this example, producer surplus and consumer surplus are both the same number, 8. That's not always guaranteed to be the case. Oftentimes you'll get different numbers. So don't always expect they're going to be the same, but in this case they are. Okay, and the last part, if you want to get total welfare, is the damage caused by this externality. So what is the total external damage? That's going to be the damage per unit times the units, or times the quantity. So let's go to my quantity. So we're causing damage of $1 per unit, and we're producing 4 units total. So that gives us that our total external damage is 4. So our total welfare, we're going to have consumer surplus plus producer surplus minus external damage. And that is 8 plus 8 minus 4, which is 12. All right, so total welfare is 12. So let's, I guess, back up for a minute and ask a question. So how is this different from if we didn't have an externality? If this was a good that was not causing externality, was not causing this damage, how would it change the outcome of these? Well, this is the market outcome. And so the market outcome is what happens without considering the cost of the externality. So if we were just sort of blind and didn't know about this external damage, and just completely ignored it and said, what is the market price and market quantity? We would get price of 4, quantity of 4. And we would get a consumer surplus of 8 and a producer surplus of 8. And we would declare that the total welfare is 16. Now, if we know that the external damage is there, then we know that it's going to cost, and we should apply it to our total welfare calculation. But important to remember that when looking at this market, even though it has an externality, nothing's actually changed in what happens. So in the presence of an externality, we haven't changed the price, we haven't changed the quantity. This is exactly what would happen if there wasn't an externality. The only thing that's different is sort of at the very end, when we're sort of adding up our total welfare, that we have this external damage that we need to subtract. So the first fundamental welfare theorem of economics says the free market gives the highest total welfare if there's no externality. So now that there is an externality and we're subtracting this, what we're going to say is now this 12 is not the highest total welfare that we can achieve. We can do something about it. We can change this situation, and we'll be able to induce an effect that actually increases the welfare of the system. Okay, so that's important to remember. With an externality, we achieve the market outcome if there's no government intervention or nothing to do it. What we get is the market outcome that just really doesn't take any consideration of the externality into effect. Okay, so what should we do about it? If we're saying, okay, with this externality, we can increase the total welfare, exactly how should we do that? So if we're looking for something that maximizes total welfare, if it's not this market allocation, well, what is it? Do we just have to sort of guess where that is, or how do we know where that is? So a guy named Pagoo was studying this problem, I think in the 1920s. It was quite a while ago. And he came up with what's known as the Pagovian tax. So I'm just going to write down our answers over here before I erase them. Okay, so Pagoo came up with the idea of, since this externality is causing damage, we're probably producing more of the good than is economically efficient. So if it's causing damage and we're not really paying attention to that damage that's being caused, we're probably producing too much of the good and we should be producing less. We're not including all of the costs that go into producing this good. So the firms that are producing it, this is sort of what their marginal costs are, but the actual marginal costs to society are higher than that. So came up with the idea of the Pagoovian tax, and this is sort of based on the idea that the polluter should pay for the pollution. Kind of makes some good sense. Intuitively, if you're just thinking about somebody's causing pollution, who should pay for that pollution? It makes sense that the firm that's producing that pollution should be the one who can pay for it. So Pagoovian tax is the principle of polluters pay. And what is the Pagoovian tax? So Pagoovian tax is set a tax exactly equal to the external damage. So whatever your external damage is, tax the good that much. So in this case, the externality is the same. We said it's $1 per unit, it's not changing. If you ever were looking at a situation where the external damage was changing depending on how much you produced, then you would sort of tax sort of along that same changing profile. So Pagoovian tax is tax exactly at the external damage, externality damage. So in this case, if we want to put a Pagoovian tax into this system, what are we going to do? We're going to add a tax of $1 per unit. So let's do that. And we're going to analyze this in the exact same ways we did before. So last time we just said, we just took a market without an externality and we added a tax and calculated how it changed the price and the quantity. We're going to follow the exact same procedure here. Much the same way if we don't do anything about the externality, we get the market allocation. Once we do add in this Pagoovian tax, we're going to wind up with sort of the same thing that's happening as if we had taxed this market without the presence of the externality. So what are our market conditions if we had a tax? We still don't want a shortage or a surplus, so we still need the quantity demanded and the quantity supplied to be the same thing. So no shortage or surplus, we still have that. But now with the tax in place, we have the price that the consumers pay is not the same as, so under market conditions we have this. With the tax, we have to add in tax. So people who are buying the product are paying what the producer gets, plus that additional tax. And so what does this mean? Our demand becomes 8 minus this new price. So now we can kind of plug this in there, and we get Q equals 8 minus, and if we plug this up here for the price paid by the demanders, we get 8 minus PS plus 1. Q equals 8 minus PS minus 1. Don't forget to follow the minus sign through there. Sort of an easy mistake to make to forget the minus sign. And what does that give us? 7 minus PS. So now we can say, okay, QD and QS are the same. So we're going to have this 7 minus PS. It's going to be the same as PS. Do a little algebra. And we find that the price paid to the suppliers is 3.5. And then we can solve for all the other things pretty quickly. We know that PS equals 3.5. Price of demand is that plus 1. And then the quantity, we could say quantity supplied is equal to the price supplied. We know price supplied is 3.5. That gives us our quantity. So, similar qualitative results as we had with the tax. We under the market, we had a quantity of 4. We now have a quantity of 3.5. The quantity that we produced has gone down. That's the case when you add a tax in, you always produce less of the good. And the price given to suppliers is 3.5. Price given to demanders of 4.5. Okay, everybody following what we're doing here? Good? Okay, so now that we've got this thing with our tax in place, we got our stuff. If we want to actually compare the total welfare, we're going to have to calculate the total welfare with this tax in place. So in order to do that, erase